இன்னைக்கு என்னென்னா ப்ராப்பர்ட்டிஸ் ஆஃப் சார்ஜஸ் பார்க்க போகிறோம் அப்புறம் கூலும்ஸ் லா. ஸோ ப்ராப்பர்ட்டிஸ் ஆஃப் சார்ஜஸ் பார்த்தீங்கன்னா we have three things. ப்ராப்பர்ட்டிஸ் ஆஃப் சார்ஜஸ் என்னென்னது? ஃபர்ஸ்ட் ஒன் additivity. Additivity is nothing but individual charges எவ்வளோ இருக்கோ எல்லாத்தையும் whenever we are adding it we will get the total charge of the total charge of the material. So individual charges நீங்கள் add பண்ணணும். Individual charges add பண்ணும்போது for example if it holds plus q plus 2q and plus 3q the total charges என்ன வரும்? q net is equivalent to plus 2q plus q plus 3q which is equivalent to 6q. இதுதான் என்னதுப்பா? Additivity. First property is additivity. Second one, conservation. Conservation is nothing but nowhere the charge can be created, nowhere it can be destroyed. That is conservation. And third one is very important property which is quantization of the charge. So what is third one? Is quantization. Quantization is nothing but which gives you the total net Q value of a system which is equivalent to Ne, where E is the charge of the electron or proton, which can be given by the integer multiple value n. N is equivalent to 0 plus or minus 1 plus or minus 2 and goes on like that. Plus gives you the positive charge, and negative value if you are getting, you may say that it is a negative charge. So these are all the three properties of charges. So what is charge? Charge is the basic element and SI unit of charge is Coulomb, and it holds the three property: additivity, conservation and quantization. So this is what first we started with the charges and how we can get the charge value. By doing the process called rubbing, we'll come to know what are all the charges, how it is getting transferred from one to another. So these details we saw in the last class. And second we ended, means we have to start the properties of the charges. And before that, what is conductivity, what is insulator, and the lies property, material which lies in between is conductor and in between the conductor and insulator is semiconductor. And what has been by earthing or grounding, that we saw in the last class. And next one is the properties of the charges. Properties of charges, it holds three properties. What are all they? Additivity, conservation and quantization. Very very important property. Always you have to remember these things. It holds the additivity. Additivity is nothing but adding the individual charge values to find the net charge of this system. For example, if the same thing here I am having any one charge which is of negative, any matter which consists of a negative, then what you have to do? Plus q. Put all the plus charges plus q plus 3q, and if one minus charge is present, then you have to just add minus. So it will get cancelled, you will get 4q. Okay. Next. Hello. Hello. Coulomb's law. Hello. Yes, ma. Can you hear me? Can't see me. Okay. Actually, it was enough. Okay. Is it okay now? Okay. Congratulations. Sir thought that you have won the match, yesterday's match. Yes, ma. Okay, so we'll start from Coulomb's law, right? Yes, Coulomb's law only we have to start, I suppose, right? So whenever there is a existence of two charges, one charge identically if it is there, initially one charge is placed at a place, there is no problem. It will just keep around it, and maybe charge, electrostatic forces existing around it. Electric field may exist, but force will not exist. See, for example, if the board is kept in this way for a long time, whether it experiences any forces? No, it does not, right? Because physically, no one is there to push or pull the board. Until and unless someone is pushing the board or pulling the board, it does not experience any force. Only one force which it experiences is gravitational force. Am I correct? Yes or no? So gravitational force acts on all the objects. We cannot say it like that. None of the charges acts. One force which always acts is, one force which acts always on the object is gravitational force. We cannot deny that one because all the objects are in stable condition only because of the gravitational force. So this board, when it is kept for a long time as it is, until and unless someone is touching it, someone is pushing it, or someone is throwing it from this place, it will not feel any force around it, right? Yes. So if the charge is kept here as it is, it will not feel any force around it until and unless some charge comes closer to it. If it is kept for a long time, whatever may be the time, it will remain in the ideal position only. None of the force it will experience until and unless some other charge is closer to the previously existing charge. You are getting me? If I kept another charge, for example, here I am keeping another charge which is a positive charge, then what will happen? It will come to know that someone is existing around me, someone is coming closer to me, or someone is there near to me. How? Because if both the charges of same charge means like charges, then what it will do? It will start feeling the repulsive force due to the presence of this charge. So both will get away from each other. Yes or no? It started experiencing some force. Am I clear now? At the same time, if I am keeping another charge minus q here, then also it will come to know the existence of the another charge. How? Both will start attracting each other. So this charge and this charge, they will start coming closer to each other because both are of opposite charges. Opposite charges will try to attract each other. Like charges will repel each other. So these two charges will get away and these two charges will come closer to each other. So it experiences a force. It may be of repulsive force due to the positive charge which is kept closer, or a negative charge. Due to the negative charge, it may experience the repulsive force. Whatever it is, either it is an attractive force or repulsive force, when it is kept in ideal condition, it does not feel any forces. It is just kept ideal. Whenever some other charge is brought closer to the previously existing charge, it may be positive core or it may be negative charge, then it starts experiencing a force which may be of repulsive force if both are like charges, attractive force if they are opposite to each other. Is this clear now when it experiences the force? Puridama? So it will start experiencing the force when more than one charge is existing near around the source charge. This is known as the source charge. So if source charge is kept ideal, no problem. It will not feel any force. But some other charge is kept closer to the previously existing charge, then it starts experiencing a force. This is what Coulomb found. That force is known as the Coulomb's force. Puridama, what is Coulomb's force? So Coulomb's force is the one whenever more than one charge, it's not only one charge, more than one charge, when they are kept on the any field, any medium, then what happens? It starts experiencing either an attractive force or repulsive force. If both are of like charges, they experience the repulsive force. If both are opposite charges, they are experiencing the attractive force between them. In common, that force is known as the Coulomb's force. Is it clear? Okay, you just write down this statement. Whenever more than one charge exists, whenever more than one charge exists in any medium, whenever more than one charge exists in any medium, it will come across either an attractive force, or repulsive force, In common, the force exists between the charges. In common, the force exists between the charges is known as Coulomb's force. And this force, but that's all. And this force depends on the magnitude of the charge. Yes or no? If it is kept 2 Coulomb charge here, okay, I am keeping the charge which is of 2 Coulomb, and another charge I am keeping which is of 5 Coulomb. And the same condition I am keeping here 2 Coulomb and here keeping 1 Coulomb. Is there the force between the two will remain same whenever there is a change in the magnitude of the charge value? It is possible? No. It may increase or it may decrease, right? Yes or no, ma? So the force between the two charges will depends on the magnitude of the charges which are kept closer or away from each other. Okay, one is it depends on the charge, that we got. And here I kept initially at 1 centimeter, and later on the same 1 Coulomb I am keeping 5 centimeter away from the charge. And this one I kept at its ideal charge, and one charge I kept as 1 Coulomb. It start experiencing a force, and the same 1 Coulomb of the charge I am taking it to the faraway value which is 5 centimeter. Whether the previous exists force and this force will remain same, is it possible? No, obvious it will vary, right? Yes or no? So what we can conclude from Coulomb's law, Coulomb said that it is forces existing between the two charges, and that force F is directly proportional to the magnitude of the two charges, which is Q1 and Q2, and inversely proportional to the square of the distance between the two charges. For example, here I kept the charge Q1 and here I kept the charge Q2, and R is the distance between the two charges. He stated that the F, force between the two charges, is directly proportional to the magnitude of the individual charges. What is the magnitude of the first charge, ma? Here what is the magnitude of the first charge? Q1. They didn't give any specific number, right? Is there any specific number given? No. What they said? It is just Q1, right? Yes or no, ma'am? So it depends on, the force depends on the magnitude of the first charge, which is Q1, and magnitude of the second charge, which is nothing but the Q2. And what is the distance between the two is R, square of the distance between the two. So F is inversely proportional to 1 by R square, and F is directly proportional to the magnitude of the two charges, which is nothing but Q1 and Q2. Why it is taken inversely, ma'am? Why inverse? What is the need? Because whenever we increase the distance, the force between the two will be very, very less. பக்கத்தில் நின்றுட்டு இருக்கும்போது நம்ம என்ன பண்ணிடலாம், வேகமாக அடிச்சிடலாம், வேகமாக தள்ளிடலாம் இல்லையா? If the person is standing away from us, it is possible to beat like the same previous one, அடித்த மாதிரி அடிக்க முடியுமா? No, it is not possible, right? Why? Because the distance between the two is increasing. Whenever we keep the magnet also same thing, right? Whenever it is brought closer to each other, then it is okay. It may experience the attractive force or repulsive force. When it is kept far away, will not feel any forces. So distance and the force value are inversely proportional to each other. So which is Q1 and Q2 are separated by the distance R. So F is inversely proportional to 1 by R square, which can be combinedly given. How can it can be combined? When both the equations are combined, F is directly proportional to Q1 and Q2 and inversely proportional to R square. So with the proportionality constant K is given by F equivalent to K into Q1 Q2 divided by R square, where K is a constant which is equivalent to 1 by 4 pi epsilon naught. Just write down the statement. Yes, force between the 2 point charges, force between 2 point charges are found that it varied inversely as the square of the distance between the charges. It varied inversely as the square of the distance between the charges and was directly proportional distance between them, distance between the charges, and was directly proportional to the product of the magnitude of the two charges and acted along the line joining the two charges. Acted along the line joining the two charges. Yes, ma'am, you are getting Coulomb's law now, what he stated and what is the statement. Any doubt in this Coulomb's law? Okay. So if the Coulombs, whatever, and what is epsilon naught? See, another parameter here we have to be very careful that F value we know which is equivalent to 1 by 4 pi epsilon naught Q1 Q2 divided by R square from the Coulomb's equation. Force is a vector quantity or scalar quantity, ma? Force. Yes, that's what they stated, the line joining, right? So it's a vector quantity. And what is the SI unit? Vector quantity, okay. What is the SI unit? Newton. Newton is the one. Force nu vandave நம்ம மைண்ட்ல உடனே வரவர் யாராவது பாருங்க. நியூட்டனாக இருக்கணும். அவர் இல்லாமல் ஒன்றுமே கிடையாது இல்லையா? So force, he found the three laws, right? Yes or no? Remember Newton's first law, second law, third law? So from that only we concluded that something is existing which is known as the force. That is the great invention. After that only all the other forces we started finding, right? So force, what is the SI unit? Newton. SI unit of force is Newton, and here also the same thing, it's a vector quantity and it's how is the SI unit Newton. And this epsilon naught is known as the permittivity. Just write down epsilon. First write down epsilon. Epsilon is nothing but, see, you will get the question based on this only. Okay. Permittivity. Epsilon is nothing but permittivity. One more question they can ask based on this only. Epsilon is the permittivity of the medium. And this epsilon is equivalent to epsilon naught into epsilon r. Epsilon is equivalent to epsilon naught into epsilon r, and epsilon naught is for air and vacuum. air and vacuum, and epsilon r is other medium. Epsilon r for other medium, which is known as relative permittivity. Relative permittivity. Noted, ma? Just note down, this is very important. What is epsilon? Epsilon is permittivity. Okay, permittivity of any medium, which can be given as epsilon is equivalent to epsilon naught into epsilon r. But for air and a vacuum, it is only epsilon naught. Other medium, we have to consider the epsilon r. That is, what is it meaning? Shall I rub this one, pa? Copied? Okay, I'll write up this. See, listen. Epsilon value we know, which is equivalent to epsilon naught into epsilon r. For air and vacuum, whenever you take the medium as air and vacuum, relative permittivity of these are all very important, which we'll be studying up to the end of the 12th. You have to remember these things. For air and vacuum, epsilon r is equivalent to 1. When epsilon r is equivalent to 1, what happens to the epsilon? If I substitute epsilon r equivalent to 1, what will happen to the epsilon, na? So that is equivalent to epsilon naught. Am I correct? Into 1. Multiplying 1 will not make any difference. So epsilon is equivalent to epsilon naught. For other medium is nothing but whenever, for example, if the charges are kept under the water, under the alcohol, under the kerosene, so some other place, salt water, okay, whenever it is kept in the other medium, then the epsilon r value will be greater than 1. Here it is equivalent to 1, so multiplying 1 will not give you any difference. Whenever it is greater than 1, is it possible to neglect the epsilon r? It is possible to neglect? It is possible, ma? Here we just multiplied by 1, so there won't be any difference. Here it is possible to neglect this epsilon r here? No. Why? Because it is greater than 1. You cannot neglect any term which is greater than 1, right? Yes or no? For example, water holds the epsilon r value equivalent to 80. Epsilon r is equivalent to 80 for water. Then what will happen to the epsilon in that case? Epsilon naught into 80, that is equivalent to 80 epsilon naught it will become, right? Am I correct? So you cannot neglect the epsilon r very easily, which is known as the relative permittivity of the medium. This relative permittivity is equivalent to 1 for air and vacuum, and the other medium it is greater than 1. Now come to the force value. So what is the general formula for force? F equivalent to 1 by 4 pi epsilon naught into Q1 Q2 divided by R square. Yes, correct? When the two charges are kept in the other medium, then what will happen? F equivalent to 1 by 4 pi. What do you have to substitute, mark here? Only epsilon r? So what is the value here? Epsilon naught into epsilon r Q1 Q2 divided by R square. Is it clear now? Force value remains same only. Yes, ma'am? Yes, you just write down. First understand, I will give you time to copy the things. Whenever the two charges, I kept the two charges Q1 and Q2 in air as a medium or vacuum as a medium, then I don't have much difference in the formula. Coulomb's force is F equivalent to 1 by 4 pi epsilon naught Q1 Q2 divided by R square only. Okay, whenever I go for another medium, then what is happening? There is a change in the epsilon. Epsilon is the permittivity, and that is equivalent to epsilon naught into epsilon r. When it becomes epsilon naught into epsilon r, what happens to the equation of force? F becomes 1 by 4 pi epsilon naught into epsilon r Q1 Q2 divided by R square. Is it clear? Okay, this value 1 by 4 by epsilon naught Q1 Q2 divided by R square. Shall I replace with the force in air? Shall I? This is what? Other medium force. Whenever It is kept in the other medium. So how we can relate? F other medium is equivalent to F air divided by epsilon r. Shall I check? 1 by 4 pi epsilon naught q1 q2 divided by r square is what now? F air. So if I want to find out the other medium, what I have to do? I have to just divide it by epsilon r to get the F other medium. Am I correct? F air divided by epsilon naught will give you F other medium. Yes or no, ma? 1 by 4 pi epsilon naught q1 q2 divided by r square is nothing but my F air. So if I want to find out the force between the two charges in the other medium, what I have to do? Find out the F air. If you know the F air, then just divide it by epsilon r, where you will get the F of other medium. Sure? Just check once again, write it down, and while writing just check whether you are able to understand the things. If not, just let me know. Because these are all the problems, or whenever we do the problems, no, you will face these things. How it is. So just be clear whether you are getting this format. Write down. Is there any doubt in the last class session, last topics? Okay. While preparing also, if you are getting any doubt, just let me know. I'll post my number too 2 days, okay? Through sir's WhatsApp number, I'll give you my number too. You just have number. And if you are having any doubt, you can contact sir also, no problem. I'll give you anyway, you just save it. If anything you want to share or any file you want like that, just inform to me. I'll give you the things, okay? Okay. And keep on writing the notes, pa. Don't miss the classwork. Because classwork is the one only who is going to help you at the last, right? Okay, ma. The next one, answer. Okay. Tell me which one is more, F air or F other medium? Which one is having, which quantity is more, F air or F other medium? Yes, ma? Why? For example, F air is equivalent to, for example, I am saying 50 Newton. Okay. And I am asking you F other medium. What you will do? What you have to do? Yes, what you have to do? F air divided by epsilon r means 50 divided by epsilon r. Am I correct? And what is the condition for this epsilon r? Epsilon r is always greater than 1, right? Yes, this is what the condition we learned. Epsilon r is always greater than 1. When this epsilon r is greater than 1, for example, 2 I am taking, 50 divided by 2. What is the value you will get? That is equivalent to 25 Newton. Am I correct? Which is more? F air or F other medium? F air. Something you are dividing. Dividing gives you lesser value or more value. One more condition is it is greater than 1. Yes? For example, here I am dividing it by 4. Then what will happen? 12.5. Am I correct? 12.5. It will go more lesser. Because epsilon r, what is the condition for epsilon r? It is always greater than 1. If it is less than 1, it may be possible. When it is the condition existing that epsilon r is greater than 1, this f other medium will be always lesser than f air. Okay, sure now? So when it is possible, whenever the two charges are kept in the air, it experiences more force comparing to the other medium. Whenever the two charges are kept in the other medium, they feel very less Coulomb's force between the two charges comparing to the air as a medium. Sure now? Any doubt pa? Just make a note ma. Because they will give you the formula for force value for F air. And they can ask you to find out the other medium. Just you have to divide it by epsilon r. No need to find out all the other things. Okay? Okay, ma, noted? Okay. And here come to yes, pa? Epsilon r they will give you ma. It depends on the medium. For example, I said no, water is having epsilon r value 80. Like that they will give you for whatever the medium it is, glass or some other things. Whatever is the medium, they will give you the epsilon r value. So there is no problem with epsilon r. Okay, and next one is epsilon naught. Another important equation which relates whenever we go for the force value, constants. Just put the value constants, very important. You keep on marking the constant values, constants. What is F? A into Q1 Q2 divided by R square, right? Yes or no, ma? This K value is a constant, I told you, right? For air, if it is air or other medium, air or vacuum, then this K is equivalent to 1 by 4 pi epsilon naught, which is equivalent to 9 into 10 to the power 9. Note on the constant. This K value is equivalent to 9 into 10 to the power 9. Unit is Newton meter square divided by Coulomb square. Newton meter square divided by Coulomb square. How to remember this one unit? What is K value from this equation? If I cross multiply, what I will get? K is equivalent to what is the SI unit? Newton. R square is distance, right? R is distance. So what is the distance SI unit? Meter. So R square, what it comes? Meter square. What is the charge SI unit? Coulomb. So divide Coulomb square. Getting? So K value only, no. So K is FR square divided by Q1 Q2. So SI unit is Newton meter square divided by Coulomb square. Sure ma? Yes? Getting? Okay. Other medium, what is the value of K? 1 by 4 pi epsilon naught into epsilon r. Yes or no ma? Oh, one other medium K is equal to 1 by 4 by epsilon naught into epsilon r, which can be rewritten as F air divided by epsilon r. F air is a constant. So if I substitute 9 into 10 to the power 9 divided by epsilon r is K other medium. Getting? I'll repeat again. Initially it will be like that only. So little bit between the difference between the which is air as a medium and other medium. K air divided by epsilon naught. This is K air, no? 1 by 4 pi epsilon naught. So K air divided by epsilon R. Sure pa? Check whether